All right, good morning, guys. So what I have planned for you today is that we're going to be going over 5-3, just an introduction to solving trig equations. So the first thing that I want to do is I want to offer you guys like a little warm-up problem to start. So the first question, and I know this might be new, but I want you to try it. Number one, I want you to find the answer to this equation. Cosine of theta is equal to 1/2. And I want you to solve it on the interval between 0 and 2 pi. So what that means is on my unit circle, I can only go one rotation up, or I could only go one rotation all the way around backwards. So I can go counterclockwise, I can go clockwise. I actually can't go backwards. I take that back. Basically what this is saying is where on the unit circle do I have a solution if I'm only allowed to go counterclockwise once around the circle. So I want you to take a pause and see what you get here. Okay, all right, let's go ahead and go over the answer. So what this question is saying is, hey, when do I have an x value? When do I have an x value of 1/2? Well, this actually reminds me a lot of when we talked about inverse trig. So what I'm looking for is, hey, when do I have an x value of negative, positive 1/2? Let me take that back. When do I have an x value of positive 1/2? Well, that's going to happen right here in the first quadrant. It's also going to happen right here in the fourth quadrant. So note here that this is not inverse trig. So there are no really restricted regions. The only restriction they gave me is that it has to be between 0 and 2 pi. Well, the first one, cosine is equal to 1/2, happens right here at pi over 3. Its ordered pair is 1/2 comma radical 3 over 2. And it also happens down here. So it also happens down here at 5 pi over 3. And so what we would say is that the answer to this is that theta is equal to pi over 3 and 5 pi over 3 on the interval 0 to 2 pi. Okay, so that is what's called a specific solution. It's a solution that's on a given interval. What happens if I want a generic solution? So the next warm-up question I want you to try is this one. I want you to solve this equation. 1/2 sine of theta is equal to negative radical 3 over 4. So go and pause the video, and I want you to try that one next. Okay, so hopefully you tried this one. The first step that I would take here is I'd probably multiply both sides by 2. So I'm going to multiply both sides by 2, leaving me with sine of theta is equal to negative radical 3 over, 4 and 2 should cancel, so negative 3 over 2. Well, that actually rings a pretty big bell for me because negative radical 3 over 2 is a huge piece of the unit circle. In fact, I'm going to go ahead and list all of the times that sine is going to be negative radical 3 over 2. So really I'm looking for when are all the y values negative radical 3 over 2. Well, that's going to happen. Let me change my color a little bit. That's going to happen down here. And it's also going to happen down here. This one right here, we already talked about that in the last question. It's 5 pi over 3. And then this one right here is 4 pi over 3. This one right here is 4 pi over 3. Except it didn't give me a closed interval at all. It just said, hey, what's the general solution? So really the question is, what's the general solution? What's the general solution? Okay, so what this is saying is that if I continue on this path, if I go around the unit circle as many times as I want, there are technically going to be infinite solutions. Let me kind of show you what I'm talking about. I could go all the way around the unit circle this way to get 5 pi over 3. I could also do this. I could go all the way around the unit circle, continue on, and go all the way around the unit circle again and still get 5 pi over 3. I could also do this. I could go down pi over 3 and also still get the same solution. So really the question is, how do I generically represent all of the solutions? Because technically there are infinite coterminal angles in this instance. So what we can do here is think about it kind of like this. In fact, I'm going to move this so I can actually go back. So what we can do here is we can think about it like this. The most basic way for me to get one of the solutions again is to do what? Well, let's think about it. First solution looks like this. Second solution I could have could be going all the way around the unit circle, which is 360 degrees, or it is 2 radians. So I went 2 radians, and then I went another 5 pi over 3. So really what we could see this as is I do 5 pi over 3 plus 2 pi of any iteration. Basically, if I do any sort of iteration of adding 2 pi, I'm going to end or start where I started. And so the first way to generically represent the answer is going to be this. We're going to take our solution. One of the solutions was 4 pi over 3. I'm going to take my solution, 4 pi over 3, and I'm going to add it to 2 pi. If I add 2 pi to 4 pi over 3, if I add 2 pi to anything, I'm going to end up where I started because I did an entire extra rotation. So basically, if I add 2 pi over 3, 2 pi, or if I subtract 2 pi, I'm going to end up exactly where I started. I'm going to have a coterminal angle. So basically, if I do any iteration of that, any, the answer is going to be this. 4 pi over 3 plus 2 pi n, and we would say that n is any integer. So basically, if I add 4 pi over 3 plus any iteration of 2 pi, positive or negative, that is going to be what's called my general solution. And we'll write that for the other one too. So the other one is going to be 5 pi over 3 plus 2 pi n. And we'll say once again, n is any integer. And if you need a quick refresher, an integer is like a whole number. So it could be negative, it could be positive, it could be -1, it could be -10, it could be 15. It's just not a decimal, okay? All right, let's move on to our next question. All right, so here are some general guidelines for solving trig equations. So number 1, you want to solve the equation using your unit circle as your guide. So in general, the unit circle is just going to give you a picture of the interval 0 to 2 pi, or technically 0 to -2 pi. All right, so number 2, you're going to determine the period of the trig function you're looking for. So in the cases that we just did, here, cosine and sine have a period of 2 pi. That's why my general solution always has a 2 pi in it. If I solve an equation with a tangent or a cotangent, I'm going to add that period times n to my solution. All right? All right, so if it's pi, your solution should occur in intervals of pi. And if it's 2 pi, it's going to occur in intervals of 2 pi. So remember that cosine, sine, cosecant, and secant are all going to have periods of 2 pi, while cotangent and tangent are going to have periods of pi. After that, you're going to apply the period to your solution to create a set of all solutions. So just note here that if you get a solution with answers in all 4 quadrants, you may be able to better simplify your general set of solutions by identifying duplicate sets, which we'll talk about a little bit later. All right, so what we're going to do first, we're just going to do a couple practice problems. First one is all about collecting like terms. So the first question that I have for you, I want you to pause this when I write it, and I want you to try this. We have cosine of x plus 1 is equal to negative cosine of x. So go and pause the video and see what you get there. Okay, so hopefully you pause the video. So the first hint is actually the title. It says collecting like terms. So what I would suggest you would do here is go ahead and move all the cosines to one side and all of the numbers to the other. So I'm going to move cosine to the other side. And I'm going to move the numbers to the other side. So what I'm going to get is 2 cosine of x is equal to -1. Okay, so I can actually simplify this more to solve. I'm going to divide by 2 on both sides. So the question is, and this, unless I'm given an interval, it is assumed that this is going to be what's called a general solution. And the reason it's assumed is they didn't give me a specific interval that my answers are going to be on, so I'm going to assume it's general. All right, so the question is, when does cosine of x equal a half, negative? Well, on my unit circle, I have cosine being negative a half here, and I have cosine being negative a half here. So once again, we saw this one earlier, that's 4 pi over 3, and this right here is 2 pi over 3. Okay, so to write this generically, I need to, number 1, ask myself, hey, what's the period of cosine? Well, hopefully remember the period of cosine is 2 pi, which means we're going to be adding 2 pi n to any solution that I see on my unit circle to make it generic. So my first solution is going to be this, 2 pi over 3 plus my period, which is 2 pi, times n, and we were going to also state that n is any integer. If you want to write this quicker, if you want to use some fancy math notation, you could also write this. We could write n, and this backwards e is actually an epsilon. It means exist. So n exists in the set z. So z is actually mathematical terms for integer. It's like I don't know. It's just the notation. Actually, I'm pretty sure it comes from some sort of German origin. I don't know if someone wants to message me about why integer is represented as z, but this is a really fast way of saying n is an integer. All right, the next one is going to be this. Well, my only other solution I see on my unit circle is 4 pi over 3. And then we're going to add every iteration of cosine's period. Well, cosine's period is 2 pi, so we're going to say plus 2 pi n, and I'm going to use the notation n exists in z. Okay. All right, so at this point, you probably have time to do one or two more. So let's go ahead and try the next type, which is called factoring. Hopefully that is going to just make us so excited to try. All right, so what I want you to do once again is once I write this, I want you to pause the video and I want you to try this one. So let's try this one. We have 3 sine of theta plus 2 sine squared theta plus 1 is equal to -1. So go ahead and pause the video, and I want you to try this one. Okay, take the fact, actually don't pause the video quite yet. Take that one out right here, and then I want you to pause the video and try this one.